All right, so for this last part, we're going to talk about section 6.3 and how we solve some exponential equations. Now, right now, we're kind of limited in how we can solve these. Really, the only way we know how to solve these right now is to get the bases to be the same. So if you look at this first problem, 4 and 256 are obviously not the same base. But if you look at 256, 256 is 16 times 16, which is 4 times 4, 4 times 4. So essentially it's a bunch of 4s. So you can rewrite 256 as 4 to the 4th, because there are 4 of them, 1, 2, 3, 4. Now the idea is you have this exponential equation with these like bases, you can just set the exponents equal. So x equals 4. Now 4 was not the only base I could have aimed for. I could have also tried to get it to be base 2, because I could have said 4 is 2 squared, and then I could have said that 256 is 2 to the 8th power, because each of these 4s, of course, break down to 2 and 2. Either way is fine. You would have got the same answer. Just depends which way you want to do it. Now, if I look at the one over here, I think there's a pretty clear way to go. We've got 1/3 and 81. So 1/3 and 81, they are both divisible by 3. So what I do know is I know 1/3 is 3 to the negative 1. That's a tricky one. Remember, if it's a fraction and you want to make it a whole number, the exponent is negative. So this right side I could write as 3 to the negative 1 times x plus 1. I want to point out that we have those parentheses we're putting there. That will be very important. So now I got to figure out 81. Can I write it as a bunch of 3s? Well, I know it's 9 and 9. I know it's 3 and 3. And I know it's 3 and 3. 1, 2, 3, 4. So this is 3 to the 4th. So once you got the bases the same, you can simply set them equal. So 4 equals negative 1 times x plus 1. So I'll distribute the negative 1. 4 equals negative x minus 1, and I'm just solving it now. So I'll add 1 to both sides. 4 equals negative x. And then to get the x by itself, I'll just divide by negative 1. So x is negative 5. So really no big deal at all as long as you get the bases to be the same. We're simply just setting the exponents equal and solving for whatever the remaining equation is. Now this last one obviously is a little trickier because it's got squares and things like that, so our old friend factoring will probably make an appearance. So my current bases are 9 and 1/3. So obviously a pretty easy base to turn these two would be 3. So I just did this one earlier, so I could do this one as 3 to the negative 1 times 2x squared minus 6. Again, I got those parentheses. And then 9 can be written as 3 squared. That's a pretty easy one. 3 times 3, so 2 3s. 8x minus 6. The problem with this one is when I write it, the exponents equal, I get 2 times 8x minus 6 equals negative 1 times 2x squared minus 6. So I'm going to have a lot of stuff going on. So if I distribute the 2, I get 16x minus 12. And if I distribute the negative 1, I get 2x squared plus 6. So because this is a quadratic, it's got the square, we're going to have to solve it as one of our quadratic methods. You could use quadratic formula, but better off would be to move everything to one side and factor it. So I'm going to add 2x squared to both sides, just because I like the square term positive, and I'm going to subtract 6. So I got my 0, so I got 2x squared plus 16x minus 18. Now, a lot of these turn out to be very, very similar. So I don't really love the 2, but I notice they're all even, so I can divide everything by 2. Get x squared plus 8x minus 9 equals 0. This one factors pretty nicely. Two numbers that multiply to -9 add to +8 are going to be 9 and -1. So my solutions are -9 and 1. So a very similar idea. The only difference in a quadratic is you have to get everything by itself, and then you, of course, just have to factor the polynomial. We got lucky in this case. They were all even. I was able to divide it to give me a pretty nice polynomial to factor.